Hi, I hope you all had a good lunch and have some energy now to pick up some more content. I'm Jendrik, and I would like to talk about how modularity in software fits into the developer productivity story, because I'm consulting different teams on the build setup, and I have seen this somehow cross-cut with the stuff I'm doing. So I work a lot on modularity stuff somehow through this. And that's what I want to talk about today. So to put this a bit into the picture also of other talks and topics we have seen today and we're going to see in this conference. So one thing that is often talked about is build performance, speed of the pipeline, stability of the pipeline. So that's something where we develop tools and get better and better at the moment. And we have tools like the velocity nowadays. So a lot of things happened in the past few years. And this can help us to answer questions and make us more productive by seeing how we can improve things. But assuming that we wouldn't have all these problems, assuming we had infinite resources somehow, just as a mind experiment, saying, okay, we would just throw all these resources, all the money at this, and then we could say, okay, these problems basically more or less would go away, right? Because we wouldn't need caching or better parallelization because things would just all finish in an instance. Of course, that will never be the case. But I just wanted to say that the context today is looking at other things that are also in the productivity area, but these are still close to the code and to the technology we are doing. So the topic basically I would like to look at is the comprehensibility of the code we are working on. So maybe you know this if you ever were there when the project started or you have your own side projects. You might have a quite small project. So it's unfortunately very hard to read on the screen, but it doesn't matter that much. It's just examples. So this is one module from a project I'm working with. So the examples I will show today are all in Java and in the Java ecosystem. But I think all the conceptual things could also be transformed or seen in other ecosystems as well. I'm quite sure. So here it's like, 10 files, and they all are not super large or something. So when you work on this, you kind of can keep this whole thing in your mind and understand what's happening in software. And if you do that, I think it feels very good. You also feel productive because you feel like you have everything under control. But when the system grows larger, it's sometimes quite hard to still understand what's going on. And you get this feeling like, I'm not really sure if I understand the whole system. And when I make the change, what's the impact everywhere? So this picture just shows this doesn't work. So it's like this module is one module in this picture, which is also not too bad, but I'll get to that. So today I want to talk about this topic and how it's connected to build tools and build performance and close the loop in the end. So this is a project I'm involved with, which is open source. So I'll have the better link at the end again, so you can look at that if you like. And this is actually not too bad. It's also not too large, as you see. So every dot is like a module is a project that these are developed or third-party module. But there are still a lot of lines between the modules, right? And so even if you work on one of these, you still kind of need to know about the context and understand the context. And this picture doesn't help you, right, when you see everything. So question is, how can we dig down, right? How can we kind of isolate the context that's important for me when I'm working on a module, on a piece of code? And that's use the same visualization as with mean, but it's another project I'm working on. And you can see there that's even much more useless to look at this picture. So you somehow need to drill down into the modules. And this is also in a super bad state regarding this whole setup. And I'll get back to that in the end. So one thing I wondered is, when you talk to developers, to the teams, they want to make their software modular and they want to make it in a good way, but somehow, and they often also start with good intention. Also this project, when it was started 15 years ago or something, it was much smaller. They actually have a definition language for their architecture, some XML formats they made up. So they had some good definition and tools that can check it, but it didn't scale. And the software grew and somehow no one adjusted that, and now it's a mess. So, and I was thinking about, okay, what are the patterns somehow, or where does this complexity in this topic come from that it's so hard to handle or so hard to maintain, and why are maybe also tools missing in this area that help us to keep it maintainable? So to kind of look at what these aspects are, I wanted to look at a small example, which is a Java project that I made up. So it's made up of two modules up here and amazing. It doesn't matter how they are called. And I use some third-party existing Java libraries. And so in this case, the picture is okay. I could keep the whole thing in my mind. But when I work on something, or first, in Java, the nice thing is, so if this is assuming this is like my architecture that I just drew down as a picture, in Java, it's actually nice because I can say every one of my conceptual modules actually becomes a folder on disk in the end with the source code in it. And when I compile it, I get one jar file that I can reuse. So I can keep this architecture kind of in the implementation, and then I can build tools and use tools to check it and make sure it's followed, or see if there are things that should be changed. So the foundation in Java, at least, is quite good actually to keep this well structured, because Java supports this modularity since ever. It allows you to compile modules on their own and then link them dynamically later when you use them. So, but still, this is, if the software grows larger, then it's important that what I already said on the pictures before, that you kind of are able to understand what's important for the context I'm working in. So when I work on this app project up here, maybe it's not important what is down here. So that this other module is using some third-party libraries as implementation details. That's not important when I work here. So I can hide things and think about, okay, if the architecture is also maybe defined like that in layers where I say, okay, when I work up here, the stuff down here is not of interest, then I can encode this somehow in the realization of the software. And then I'm able to, I know what the scope is, what the scope of the dependencies is when they are visible, and I can focus on certain aspects and understand this part of the system and know the dependencies. And this is not only true for my own modules, but also when I use existing modules, either open source things or modules developed by other teams in my company. I still have the case that there are often these transitive dependencies, right? You use this one, but this one is also needed somehow down the line. And then there's the question, okay, do I need to care about that down there is something else, or do I not need to care about this? And if the developers of this module here, if they provide enough information somehow to the tools, the tool can help you to tell you, is this needed or is this just some implementation detail that you don't need to worry about when you work on it. So that's why I call it an essential complexity. When you define these things in your code, you could say, I define a dependency, I somehow need to think about where is it visible. That's complex to think about, but it makes sense, right, to think about it and to understand what it means. Not just say, I don't really care. I don't just need the dependency now. So the scoping is kind of important. The other thing is that when you use modules that you don't control yourself, there's never just one version or one variant of the module. There are a lot of versions out there, and you need to choose which one to use. And then when you have this ecosystem like in Java, where you have so many frameworks and libraries, we often have the situation that they depend on each other. And so you use framework A and you use framework B, and they both use, like here I have this example of comments lang, one library. Then someone says, I need version 14, the other one says, I need version 15. So you have this conflict, and the very usual reaction is that people are just, damn, why is this so complicated? Why do I have these conflicts? I just wish to go them away, and tools like maybe in Gradle, they can handle some of these automatically in a certain way, but sometimes the automatic handling doesn't work, and then you need to understand what's going on, and you need to kind of give a resolution to the tool. And I think it's also, this is a mindset thing in my mind, so you have to, or you should think about this not as a bad thing, but as a small price you pay for this, all the gain you have by being able to reuse all these libraries and frameworks and combine them in new ways. But so this is also not something that is somehow accidental or complexity that we don't want to have. This is inherent to how this whole reuse context works, the whole system. And and then we don't have just versions. We also have other dimensions of variations for modules. So for example, down here, hard to see, but this is a JavaFX framework. It's a UI framework, and they actually have different jars for different operating systems. So you also need to choose, do I want this to build this for Mac or for Windows, for example. So there are other dimensions of variation that you need to deal with, or the tools also need to deal with. And then kind of a third thing that, we could wish for going away, but I guess it never will, is that things are not perfect. So, as before, everything down here in this example is out of your control. So they're developed by other teams, by folks you maybe don't even know who it is. So if there's something missing in information which you want to use, for example, the information, what I said, is this actually needed down here or not? If the information that comes with the module, so the metadata that somehow comes to them, is not providing the information, then you somehow have to write it yourself. You can report back to the developers and improve things for everyone, but it's something you just have to, or something you need to be aware that you should deal with that things might be missing or wrong in the modules you are reusing from somewhere else. Okay, and just to emphasize, if I would do this project now with Gradle, so define these two modules and just say dependencies to these things I'm using, it doesn't build a working software because of this missing information. Yeah? So that's why, for example, here we don't select it. It actually selects empty jars, so it doesn't work on any operating system, which is stupid, but it's how it is right now. And then there's a module in there which I don't actually need, and so on. So okay, and when these things happen, then you're already at the point where this is really getting complicated, and how do the tools help me, and what do we do there? And I think at this point, we are at the point at the moment where the tools are not good enough in this area, and where also the knowledge is somehow not insufficient, just because we put this topic on the side for several reasons, and that's what I want to talk about now. So what else is making this complex right now? And this is really from what I've seen in projects I've been working on, and where we try to improve the situation on these things. So these are two examples from open source projects. So the first thing which I found is making this topic so complicated is that when you deal with these dependencies and say, I work on code of a module and I need something else, then it's something that's the responsibility of the developers who work on the code. While everything else that you do with tools like Maven and Gradle is stuff that is configuring the build, which ideally as a developer you don't even want to see. You just want it to work. But at least Java, the language, it has this modularity, what I talked about, but it doesn't offer you, at least in older Java versions, it doesn't offer you the possibility to define these things. You can't say in Java directly, I need this module. You can only say it when you call the compiler, you can give a class path argument and put in some jars, and that's why Maven and Gradle picked up this topic, basically. They are building this on top of the language, but they are providing something that should be used by the developers who use the language, who write code in Java, but that's the first thing that in the mind of the developer can often be a blocker in this, that they say, okay, now I have to use this notation here, Groovy, Kotlin, 20 different notations. What is this? Why should I use this? Or why should I do some XML? And when you look at these examples, actually these build files, they contain this dependencies block, but it's only 20 lines of code and the file is 300 lines long. So there's a lot of other stuff around that makes it even harder to understand which part are allowed to touch and which I'm not allowed to touch. So right now, most projects I see, they mix this. They mix the dependency topic, which is for me not a build topic in the first place. It's about the structure of your software and encoding the architecture or the structure in your actual implementation. And the other stuff, like, I don't know, which test frameworks do I configure how, and which compiler flags do I pass. This is configuration of the build, which you maybe also don't need to touch every day or for months or years. And so this is something the tools mix right now very, very strongly. And I think that's already the entry point why many people that work on code are just start not thinking about the topics I said before. And then, for example, the scope topic, I know one effect where I see this is when you just Google, how do I add dependencies, something in Java, you usually get to this page, and it doesn't even tell you that you could define a different scope when you use Maven. When you use Gradle, it uses this one scope implementation, but you could use other scopes, and it doesn't say this on this page. I mean, you should probably know it when you use Gradle, but I think it's somehow showing how too little this topic is cared about when you develop. Yeah, and then a big issue I see in Java at the moment is this metadata, I mentioned this before, is not sufficient enough for many libraries. I don't want to go into too much detail today, but it's somehow blocking. We have this POM 4.0 format, which comes from Maven, but it hadn't evolved for many, many years, and it can't hold much information. So Gradle developed this other format, this .module format, which can hold much more information, which is actually quite good with this, but it's not used much, which may be understandable because it's a Gradle format and no other tool supports it. So it's kind of a weird situation we're in right now. Then there's a format from Java itself. I will get to that in a few minutes in the talk, which is also supported. In this case, this one is there, but in other cases, the other ones are there, this one is missing. So it's kind of something where you wonder why it hasn't evolved earlier, but it's evolving, it's getting better, but it's something you should be aware of, that when you use third-party libraries, there might not be enough information for the tools to help you enough with this whole conflict situation and so on. So what can we do better right now with the tools we have, and what can we learn from that to maybe improve the tools and the everything around it? So what I'm going to show now is something that we actually strive for in several projects that I'm involved with, and which I think is a good like a pattern you can do to do things better with how things are now. So let's look at this project, how it looks in real. So this is a real small example project. I'll give you a link in the end of the presentation if you want to look at this on your own. And here it's designed like this. So I have the repository, and here I have a folder which I call modules for my source code. And up here I have a folder called Gradle for the build system. So these two things are clearly separated. Here's stuff in there for the build configuration, and here I develop code. And then inside the module folder, there are only two files, or in each module there's one file with this Gradle name in it, build Gradle KTS. But in the file, there's only this dependencies block, nothing else. Only this one for the developers. So they only need to understand, when they don't want to care about the other parts of the build, only to understand this part of Gradle, which is actually about my modular structure of my software and not about anything else. And then everything else is put into this Gradle folder. And I won't go through all the stuff in this example here, but things like, compiler options or something like that, they are concentrated here in this other part of the repository. They could even be in a different repository. So they are not, they are the build configuration. They are not the modularization of my software. And then for this topic I talked about already a lot, that we don't have sufficient metadata and information about some modules. That is what I put here in a centralized place where I say, okay, I know I have certain metadata information missing for certain libraries. Like down here is this missing information for the Linux, Mac, Windows stuff. I can add it here so that Gradle is then able to interpret the information about the modules correctly and select the version. For example, when I build on Windows, it selects the Windows version. And the information is added here. And then let's go back here. When I say I would need JavaFX graphics, I say I need JavaFX graphics, but I don't say I need Windows or Mac or something. That's something the build system can then decide depending on which target or which task in Gradle I call, or for which platform I want to build. And then I mentioned this before, Java has since version 9, it has this a new feature called Java Module System, also called JPMS sometimes, which is not widely used, but which is actually doing exactly this. And maybe it should be more used in the future. I think it should, because it now gives a notation in Java itself that allows you to actually define this, what I just said. So this module info Java file is the format defined as part of the Java specification. It's fixed, it won't change. It doesn't have variation like Gradle has. It's always the same notation. And I won't go into too much detail here as well, but here you also see there's some identifier, JavaFX graphics, and then there's a keyword here requires, which is actually a scope. So when you know Gradle, it would be the implementation scope, and there's requires transitive, which would be API scope. So these concepts are actually available in Java now, and I'm involved in a small project called Gradle X, where we develop some plugins to integrate these things better. So in this project, we use those plugins, and then Gradle can pick up the information here. And so we don't need a big Gradle file at all. As you see, now we only have Java code or only Java notation inside our modules folder and nothing from the build system anymore. And in theory now, if Maven would have a similar integration or similar plugin, which I'm convinced we could build, I also talked to some great Maven developers already, then you could basically exchange the build system in the background and won't need touch anything on your code. And then when we have this, I think then we can start to build better tooling on top of that also helps the developers to better understand the concepts the scoping and also maybe recognize the importance of it. One plugin that already exists is this dependency analysis plugin, which I can recommend to everyone that is using Gradle. Also, if you don't change anything else, you can just use the plugin, and that checks some things like is the dependency actually used in code that you defined. So, and when you do that, you will make sure that this list, or this list if you use traditional, that this actually reflects what's in the code. And then you can go back and see, let's look at my architecture. Does this still conform to the architecture? And you have like more traceability from the actual architecture structure that you want to the definition in the code. And it's something someone who works on the code can look at and work with more clearly than when it's also mixed up with the build definition. All right. So I will share a link to this example in the end. You can find it if you want to take a closer look, or you can also talk to me about it if you're interested. Okay, let's summarize this again, but I think I've said everything what I want to say about this. So we have these 3 topics I tried to motivate in the beginning that they are important to know about when you do modularity in Java, but I think in other ecosystems you find similar things. I'm quite convinced. And then I had, in the second part, I've talked about this like complexity, accidental complexity that we see in projects today, and tried to analyze what the reason for that is, and said, okay, the mix with the build definition could be improved just by following certain patterns with the build tools today. And in Gradle, Maven it's a bit harder, I think, right now, but in Gradle it's possible to do this, just like I said, that you really only put the dependency definition into the project. And then everything else comes like with that. So in Java, you could even use this unified Java syntax, which is build tool independent. Then you get closer and closer to Java itself when you work on this topic. And I think something was super underestimated is this variant version selection, which is kind of just usually in many projects, it's just people just do something that it works, and then, okay. Gradle actually has a lot of systems built in now to handle this, like Kotlin multi-platform, for example, is using it extensively because you have like variations for all the platforms for almost every library. And it's just that it's, not so well known, well understood, and also things like feedback messages you get when there is a conflict that can't be resolved, they could all be much better, right? There's a lot of room for improvement. And then be aware that when something is not working, often the reason is that the tool does not have enough information, that the metadata is wrong or incomplete, and that is a place where you can fix it. And well, at least that's possible. Everything is there. You just need to know which part of Gradle to use for that. So to kind of close the loop to the beginning, where I said, okay, if we wouldn't have this performance issues because we have infinite fast CPUs and memory and so on, then we could do a lot here. It's of course not the case. We have the performance problem, and it's a very important issue. But these things also play together, right? If you make your modularity cleaner and develop with smaller modules and have clean dependency definitions, it's again information Gradle, for instance, can use to decide does something need to be recompiled again. If you change something down here and it doesn't influence things up here, Gradle won't compile this again when you change it down here. So also better modularity can lead to better build performance and faster tool chains. But I think the motivation for improving the modularity should be the comprehensibility. You shouldn't say, we can, but I think that saying I have a large module and I want to cut it down for performance reasons only is maybe not the right approach, but thinking about, okay, how can I make my software better structured so it's easier to understand the piece of code I'm working on. All right. And this is very subjective, so I'm working mostly with, like I would say, smaller companies compared to companies many of you work for. And they don't have their own teams that build tools for this. But there are tools you can use, like the build tools themselves, which are open source, or the Velocity. And I think in this area, so we have quite some off-the-shelf tools that you can buy, license, or just use. I mean, there's still a lot of that could be improved and could be shared in the area of build performance. But I think in the area of this whole topic of making the modularity aspect of a project better understandable to kind of make it, improve this comprehensibility aspect, I feel like we don't have many tools that can just be used and plugged in. At least in Java, I struggle to find things. But maybe some of you know some things, so I would be happy to discuss this. Maybe in other ecosystem situations also better in this regard. So it would be interesting to to talk about that. Yeah, then thank you very much. I don't know if this is, so it's not all very good readable here, but I have this GitHub page, Jendrik.Johannes. If you just remember that, everything is linked from there. There's one repository which is called Java Module System because, the project is like that and it talks like that on other conferences as well. This contains the example project I showed, and there are other examples with the same setup. I also have a channel on YouTube with videos about Gradle, and I have a playlist about Java modularity where I talk more about the technical details of how this all works. So if you're interested, you can take a look there. And I'm here today and tomorrow, so please approach me if you find this interesting to discuss about the topic. And if you don't have time for that, you can always get in touch with me. It's also linked on my GitHub page, so my email address and my LinkedIn. So please feel free to get in touch. Okay, I think that's what I wanted to say. Thank you very much.